Hi everyone! In this video, I just wanted to go over some review material for the Spinach lab. So in this lab, the goal is to extract pigments from spinach and then analyze those pigments using thin layer chromatography and UV-Vis spectroscopy. So let's go over UV-Vis spectroscopy because it might have been a while since you've thought about these techniques. So with ultraviolet visible spectroscopy or UV-Vis spectroscopy, we're trying to visualize what colors are absorbed or transmitted. So typically you'll see some sort of spectrum where you have transmittance on the, actually for our lab it's absorbance. So you'll have absorbance on the y-axis and then wave numbers on the x-axis. And wave numbers are in inverse centimeters. So you might see, let's say, something like this, and this is going to tell you what colors are absorbed and which colors are not absorbed or transmitted by a particular sample. Now remember, when you have a chart like this, the highest peak is your lambda max, so that's your highest wavelength value. And that's typically where we do our analysis. So if we were to plot that point as xy, that would tell us our wave number or wavelength and absorbance. Now, what's really useful about that is we can plug in our absorbance into the Beer-Lambert law. Although often we just shorten this to Beer's law. So Beer's law tells us that the absorbance of a sample is equal to something called the molar absorptivity, which is given the symbol epsilon, times the path length of your sample, so how far light is traveling through your sample, and that's given the symbol B, and then we multiply that by concentration. So again, A is absorbance, epsilon is a molar absorptivity, and that's usually a constant that you find, or you can also calculate it depending on what data you have. B is our path length, and that's often going to be the width of your cuvette. So remember, typically we put our sample in a little cuvette, and then light passes through it. And that is 1 centimeter wide, so that's usually our path length. And then C stands for concentration. Okay, so in your lab handout, you are told that you'll have to calculate the concentration of carotene, which is one of your pigments, in your solution. So what you'll do is you will run a UV-Vis spectrum for carotene, and you're going to find the highest point, and that's going to be your lambda max value, and that is also where you're going to record the absorbance for your sample. Then you're going to plug in the absorbance value into the Beer-Lambert law. You're also given the epsilon value in your lab handout, so you'll plug that in. We know that the path length is 1 centimeter, and then you're just going to calculate the concentration. So if we rearrange this equation, we would take the absorbance and divide it by epsilon and the path length. In your post lab, you're also asked to determine the number of milligrams of carotene in your sample. So once you have your concentration, remember the units will be moles per liter. And what you can do is cancel out liters by multiplying the concentration by the total volume of solution. And you can find the total volume that was used in the lab data document. Now, you might have to convert milliliters to liters in that step, so just be careful with your units. So that will give you moles of your sample. Then in the next step, you'll want to convert moles of your sample into grams. So we'll multiply this by the molar mass. And then finally, we'll just convert grams into milligrams. And I'll let you figure out how to do that step. Now, one thing to keep in mind during the lab, we only used half of our sample. So if you haven't watched the lab yet, that's okay. But what you'll find is we only use half of our sample to analyze. And so you'll want to take the amount of milligrams and multiply it by 2 to get the actual amount in the original sample. All right. So hopefully that helps a little bit with the calculations for the lab, and hopefully this is good review of Beer's law, or the Beer-Lambert law. So if it's been a while since you've thought about UV-Vis spectroscopy and you get a little confused, don't worry, you can always email me or set up an office hour and we can go over that together. All right, good luck.